So I'm Rosenberg from Unanimous AI, and I am here today because artificial intelligence is going to disrupt your industry. And that's scary. It's probably scary to a number of people here. It's scary to me, mostly because most AI companies are working to replace people with algorithms. And that doesn't sound like the greatest idea, especially in an industry that's all about people. But it doesn't have to go this way. And I'm here today to talk about a technology that doesn't replace people with AI, but connects people with AI, allowing us to be smarter together. And so today I'll talk about artificial intelligence and the power of hive minds. And so let me start off with a controversial statement in the world of AI, which is people are smart. Really smart. Every single person in this room has about 85 billion neurons in your heads. And every one of those neurons is connected to thousands of others, which means there's over 100 trillion connections inside of every human brain. It's the system formed by these interconnected neurons that make you who you are, not just your intelligence, your personality, your creativity, your values and morals. Every one of us is this complex system of neurons. It's remarkable. After all, we humans are pretty damn smart. We've created art, science, literature, The Simpsons. What's also remarkable is how quickly we got so smart. If you go back just 2 million years, our brains were 1/3 the size. We didn't even have language, let alone math and physics. But then the evolutionary pressures got so intense that for us to survive, we had to become the smartest creatures on the planet. So here we are, the most intelligent species on Earth. Congratulations. The question is, can we get smarter? And I'm here to say that the answer is yes, if we use AI to amplify human intelligence rather than replace it. And so let me start off with an example. Last year, CBS Interactive challenged us at Unanimous AI to predict the Kentucky Derby. And not just the winner, the first 4 horses in order. And in horse racing, that's called the superfecta. And last year, it went off at 540 to 1 odds. Now, at Unanimous AI, we don't know anything about horse racing. We had never done anything like this before, but we were game. And so we took on this project, and we started the way we always start, with people. In this case, we started with 20 horse racing enthusiasts. Not experts, just enthusiasts, who we could connect to online, and we had them come into our system. And the way our process works is we take real people, and we connect them together with AI algorithms to build an amplified intelligence. And this process is generally referred to as artificial swarm intelligence or swarm AI, because it's based on how swarms in nature amplify the intelligence of groups. Now, I will get into the details of what swarm AI is and how it works, but first let me finish this story. So we built this swarm AI for CBS Interactive, and we had it predict who's going to come in first, who's going to come in second, third, fourth for the Kentucky Derby. And so basically, we generated optimized insights. And we were doing this for horse racing, but you could do this for anything, for insights about a product, a service, a marketing message. We generated these optimized insights, and we gave it to the reporter at CBS. And she wrote a story about it. And in fact, she went to the Kentucky Derby, and she placed a bet on the superfecta, and she tweeted out her ticket, which put pressure on us. And so the question, of course, is, well, how did we do? Well, we were perfect. And so anybody who had placed a $20 bet on those 4 horses would have won $11,000. I placed a $20 bet and won $11,000. The reporter placed a bet. A bunch of her readers placed bets. In fact, one of her readers reported winning $50,000. So that's an amazing story. But what's even more interesting to me is if we go and we look at those 20 people who made up that swarm intelligence, that hive mind, not a single one of them predicted all 4 horses correctly on their own. In fact, had they taken a vote, they would have only gotten 1 horse right out of 4. But when they're thinking together as a swarm AI system, they were perfect. And so that's the power of swarm intelligence. So what is swarm AI? It's a process where we start with networked human groups. And these are groups of people out there on the internet who have knowledge and wisdom and insights and intuition. And we connect them together with AI algorithms to build an artificial super expert, a super expert that you can ask questions to about anything to generate insights. And we use this to create more accurate predictions and decisions and evaluations and forecasts and recommendations. And so that's the basic process. Question, of course, is, well, how does it work? And it's based on nature, and actually, it all goes back to the birds and the bees, and fish, and ants. All of these creatures have evolved methods of amplifying their intelligence by thinking together in systems. This is why birds flock, and fish school, and bees swarm. They are smarter together than alone. Now, I'm not talking about crowdsourcing, like we humans do by taking votes and polls and surveys. I'm talking about forming systems, real-time systems with feedback loops that are so deeply connected that a new intelligence forms, an emergent intelligence with its own personality and intellect. I'm talking about forming a hive mind. Now, biologists call this swarm intelligence, and it's actually a natural step in the evolution of most social species. And so what is swarm intelligence in nature? Well, what biologists have found is that nature has evolved these methods of amplifying the intelligence of groups, of taking the knowledge and wisdom that's out in the population and maximizing it. Now, what nature does not do is nature does not take polls, conduct surveys, run focus groups. There's no survey monkey in nature. What nature also doesn't do is analyze big historical data sets. There's no big data in nature. What nature does is it forms systems. It forms these real-time systems where groups can think together, populations can think together as a group and converge on optimal solutions. And then when they do this, they become smarter together than alone. The way I like to think about it, a brain is a system of neurons that's so deeply connected that an intelligence forms. A swarm is a system of brains so deeply connected that a superintelligence forms. So you can think of a swarm or a hive mind as basically a brain of brains. Now, let me give you a natural example. So how smart are these swarms? So in nature, the type of organism that's the best understood is actually the honeybee. It's been studied for 60 years. Biologists know a lot about it. And it is this great example of a hive mind. So this picture here is about 10,000 bees. And they have a very, very difficult problem to solve. They need to find a new home to move into. Now, that new home could be a hole in a log or the hole in the side of a building, or if you're unlucky like I was, a crawl space in your garage. Now, this sounds like a simple problem, but this is actually a life or death decision that could impact the survival of the colony for generations. And so the way honeybees solve this really, really difficult problem is they send out scout bees, hundreds of scout bees that search a 30-square-mile area to look for potential home sites. These are basically consumers who are out there in the world, and they are looking for potential homes that this colony could move into. They're out there collecting data. It's this data collection process, and they find dozens of potential sites, and they bring that information back to the colony. And that's actually the easy part of the process, because they then need to find the best possible home of all the options that they found to move into. Their survival depends on it. And it turns out that this is a complex, multivariable problem. Why? Because honeybees are very discriminating house hunters. They are skilled consumers. And when honeybees need to pick a home, they have all these constraints. They need to find a home that's large enough to store the honey they need for the winter. It needs to be ventilated well enough to stay cool in the summer. It needs to be insulated well enough to stay warm on cold nights. It has to have an entrance that's small enough to block predators, but big enough for a lot of bee traffic to go in and out. It needs to be waterproof so it's protected from the rain. It needs to be near water for bees to drink. And it needs to be well located near good sources of pollen. This is a complex problem with lots of competing constraints. And to solve it, to pick the best solution would require a multivariable optimization. A honeybee could not possibly comprehend this problem. A honeybee has a brain that's smaller than a grain of sand, and it has less than 1 million neurons. You have 85 billion neurons. So however smart you think you are, divide that by 85,000, and that's a honeybee. You probably wouldn't want a honeybee to pick a new home for you. In fact, if you were a human CEO trying to solve this problem, it would be very difficult. And there's a lot of similar problems that business executives and CEOs need to find, like finding the perfect location for a new factory, or the perfect set of product features for a new product, or the perfect marketing message for a new campaign. And they generally have lots of competing constraints, and to find the optimal solution, the best solution, is really, really difficult. A person would have a hard time finding the optimal solution for all these competing constraints for honeybees. And yet honeybees, using swarm intelligence, biologists have found they find the best possible solution over 80% of the time, and when they don't pick the best solution, they pick the second best solution. So the question is, well, how do these tiny bees do it? They do it by forming an intelligent system where they bring in noisy data about the world, consumer preferences that are coming in about all these different houses that they've seen. They bring in this noisy data about the world, they process it as a system, and they generate these optimized solutions. Now, I know what you're thinking. These are honeybees. How do they process data? They actually do it by vibrating their bodies. Biologists call this a waggle dance, because to us humans, it looks like the bees are dancing, but really they're generating signals that represent their support for the various home sites that are under consideration. And by combining these signals, the bees engage in this multi-directional tug of war, pushing and pulling on the solution until they converge on the one solution that they can best agree upon, and it's almost always the optimal solution. Which raises this question: well, what about us, people? Can people form a swarm intelligence? If birds and bees and fish can form a brain of brains and get smarter together, why can't people do it? And so that's what I've been working on for a number of years, and at our company, Unanimous AI, we've been studying this, and the answer to this question is yes. People can form a swarm intelligence. And so for years, we've been studying how natural swarms amplify the intelligence of groups, and we've been creating the algorithms and interfaces that allow humans to form similar swarms online. And so this is a human swarm. It's about 100 people, and they're all working together to move that glass puck. Each of the little magnets you see is controlled by a person logged in from somewhere around the world, and by adjusting the position and orientation of their magnets, they are basically pushing and pulling on the system in much the same way that honeybees do by waggle dancing. And so how can a swarm like this answer questions and generate insights? So let me give another example. Last year, actually for the last couple of years, Newsweek has asked us to predict the Oscars using swarm intelligence. And so what we did was we start the way we always start, with people. And so we started with 50 movie fans, not experts, just regular movie fans. And we had them come into our cloud-based server called Swarm, and they log in. And once they log in, we can have them all answer questions at the exact same time, working together as this hive mind system. And so what does that look like? So a question will appear on all their screens at the same time. And so in this case, it's who will win Best Actress in a leading role? And then the options will appear on all their screens at the same time. And so there's Kate Blanchett and Brie Larson and Jennifer Lawrence. And then each of the participants who have logged in can control a little magnet. And that magnet allows them to express the magnitude and direction of their conviction in real time. People can't waggle dance, but they can use a mouse or a touch screen or a phone to interact with this system. And so this is what it looks like with 50 people working together as a system, pushing and pulling, moderated by AI algorithms as they converge on an answer. And so they converge on Brie Larson. And so then we generate this insight, and we did this for each of the categories. And so here's who will win Best Actor. And we give those insights to Newsweek, which publishes the predictions, which puts pressure on us. And then the question is, well, how did we do? And so it's really interesting to look first at the individuals. So in this case, there were 50 individuals, and on their own, they were 40% accurate. which doesn't sound great, but predicting the Oscars is hard. There's a lot of different categories, a lot of choices in each category. We can also look at what would happen if these 50 people just took a vote. And generally that's referred to as crowdsourcing, or a crowd. Majority vote, they get a little bit smarter. There is some wisdom in crowds. They go up to 47% accurate. But then what happens when they work together as a system, moderated by AI, they jumped all the way up to 76% accurate in predicting the Oscars. And what's really interesting is we can compare to professional movie critics, experts. The average professional movie critic was 64% accurate. And so what we're seeing here is that 50 regular people, just movie fans, when working together as a system, outperformed the vast majority of experts. They outperformed the New York Times, the LA Times, the Hollywood Reporter, Variety magazine. And so it's an example of building this artificial super expert that you can ask questions to and get deep insights. Now, there was another Oscars just a few weeks ago, so you're probably wondering, well, how do we do in 2018? The technology keeps getting smarter. This year, the swarm of 50 people were 94% accurate in predicting the Oscars and outperformed every expert that we could find, Variety, LA Times, Vanity Fair, even outperformed Gold Derby. And if you're familiar with Gold Derby, what they do is they take a massive poll of hundreds of thousands of people, which again shows that, yeah, you can try to tap the intelligence of a population by taking a poll, but it's not the efficient way to do it, which is why that's not how nature generates insights. A small swarm of 50 people is almost always more accurate than a large-scale poll. So what are the business applications of building a hive mind like this using swarm AI? We like to think of it in two categories. There's consumer intelligence and business intelligence. And so for consumer intelligence, what we can do is we can build basically a swarm, an artificial expert of consumers, of either your current customers or prospect customers. Generate this artificial expert consumer and ask it questions about anything. And we can do that to generate market intelligence, product planning information, advertising and messaging evaluation. We did a project for a large fast food chain where they wanted to assess how some advertisements, actually there were pancake advertisements, how the pancake advertisements, TV spots, would resonate with the population. And so we had this swarm of people connected from around the US, and the TV spot popped up on all their screens. They were able to watch the TV spot, and then together they could predict if that advertisement would drive consumers to that restaurant. And so with consumer intelligence, the idea is that there's all this knowledge and wisdom and insight and intuition out there in the population of consumers, and we can build an expert and ask it questions and generate really interesting, deep insights. When it comes to business intelligence, the idea is that in every business, especially large companies, there's a vast amount of information in the people themselves, in the sales team, or the field organization, or the executives, or the analysts. And so we can build an artificial expert. In fact, for this same fast food restaurant, they were looking at, can they optimize their menus? And the first idea was, well, we can build an artificial expert of customers and see how they would react to different menus. But in a large organization like this, has thousands of restaurants, which means thousands of restaurant managers, which means we can build an artificial expert built from restaurant managers who have knowledge and wisdom and insight about how consumers react to changes in menus, and we can amplify their intelligence and converge on optimal insights. And so for business intelligence, we can basically take business teams and build this artificial expert. And we can do that for, say, strategic planning or financial forecasting, competitive analysis. We've done that for sales forecasting. And so this swarm insight is what we call the process when we build these artificial experts for large companies. We've done that work for actually a number of agencies that are here. We've done it for other big companies, CNN, Deloitte, Boeing. And while I'd like to give an example, but I can't talk about the specific projects we've done for business customers, so I'll give an example that is from a journalist. And we do a lot of insights for journalists. Here's one we did for TechCrunch, where they wanted to generate insights around self-driving cars. And the question that they wanted to answer was what's going to be the product feature that drives adoption of self-driving cars? And they did a large-scale survey to try to generate insights. And when they did this large-scale survey, they got the answer that safety was going to be the feature that drives adoption of self-driving cars. And they were a little bit skeptical about that result, and they came to us and said, can we generate a swarm AI? And so we pulled together a swarm of driving-age Americans around the US. It was 134 people, and we were able to then build this artificial expert and ask it questions. And so here's an example of one of those questions: what will be the greatest benefit of self-driving cars? And this is what it looks like with 134 people pushing and pulling and converging on an answer moderated by AI algorithms. And the AI is watching the behavior of every single person and finding the path that maximizes their collective conviction in the answer. And in this case, they converged on time to do other things. And so we went back to TechCrunch and we said, well, if you want to resonate with the whole population about what product feature is going to drive adoption of self-driving cars, it's time to do other things. It's not safety. Now, of course, you're wondering, well, if the poll tells you one thing and a swarm AI, its artificial expert, tells you something else, like, why is that? And a really cool thing is that when we do a swarm like this, we're collecting massive amounts of data because the software is watching exactly how every single person is behaving. And it's those behaviors that are revealing their true sentiments. And so we can plot that data in interesting ways. And so here's something we call faction analysis, where we can see each of those different color bands is support for one of the different product features. And it shows over time how this group basically negotiates and converges on the answer that they can best agree upon. And so at time step 0, at the start of it, you can see that the group is pretty split, and the light blue bar is safety. The largest plurality was safety. And so if you had taken a poll, the poll would have revealed to you what the most popular answer was if people have this simple choice. But it doesn't really tell you how much conviction they have. It doesn't tell you what the group would actually converge upon if they had to agree upon a solution. But the swarm will actually find that solution. It will find the answer that maximizes the collective confidence and conviction of the group, and it reveals that time to do other things is this actually much stronger sentiment in the population. And once we have this data about how people behave, we can look at it in lots of different ways. And so here we see how people changed between factions. And so we can see which factions, which product features were people entrenched on, which product features were people flexible, willing to consider, which types of people were entrenched, which types of people were flexible, what options would they never consider, which options were they struggling to choose among. And we can look at that by demographic. We can look at that by their age, gender, and so we get these really, really deep insights about how a population can converge on an answer. And so when we think about building this hive mind, we can essentially watch how it comes to a decision. And so every single question immediately gives us this wealth of data about how a population converges on the solution that they reached. And so we know more than just the final answer. We know why it is the final answer. And so basically, in summary, at Unanimous AI, our philosophy for artificial intelligence starts with this premise that people are smart. People have knowledge and wisdom and insights and intuition. And what we aim to do is build these network groups of people, connect people together with AI algorithms so that we can build artificial experts and have those artificial experts answer questions, generate insights really about any topic. I've got about 5 minutes left, so happy to take some questions if.
Plenty of them came in. So the first question that came in is, how does swarm intelligence address unconscious bias?
Yeah, so bias is obviously a really interesting and important thing. We try to understand the sentiments of a population. And it's a great point that was brought up, that it was unconscious bias, because people very often don't know how they really feel. And if you ask people on a survey to tell you how they feel, they are basically bad at reporting their own feelings. When we have people behave in a swarm, we're not actually relying on how they report, we're actually watching how they behave. So even if they don't know exactly how they feel, their behaviors are revealed to the AI algorithms, and we end up getting these very, very accurate insights because when we get people to behave in a system, they're forcing each other to basically reveal more about their true feelings than they would ordinarily.
One more. What is your point of view on swarm intelligence on predicting election results?
Yeah, no, it's, so we did a lot of predictions in the last election cycle for various journalists, and we do predictions before and after various debates, and in the last election cycle, we were finding, especially when we were during the Republican primary process, we were finding really, really strong support for Donald Trump, even when the polls weren't saying that Donald Trump was going to be a serious candidate. And in fact, we started to think, like, is there something wrong with our algorithms? Because the swarms were so different than the polls. We saw similar results with Bernie Sanders. We saw so much support very, very early on in these swarms coming up for Bernie Sanders when the polls weren't reflecting that. And the thing is, polls, the problem with polls is that they're polarizing. They're not asking a group of people to tell us what they can agree upon. They're asking a group of people to tell us where they disagree. And then polls are self-perpetuating, because once they polarize a population, they force people to entrench. Swarms are actually the opposite. They're not revealing where people are different, they're revealing where people agree. And so you could find those sentiments that actually allow groups to converge. And that's really why nature uses swarms and not polls, because if nature was trying to make decisions with polls and got into these dysfunctional, entrenched situations like we often do in politics, the honeybee colony would just die. All of those honeybee colonies for millions of years that entrenched the way people do are dead. And evolution pushed forward this process that allows us to really find where a population can agree as opposed to how populations diverge.
I'm afraid we're out of time for
Okay.
more, but there are many others. Thank
Yeah.
you very much, Louis, for wrapping up the day.